Yes, it's working now. Hi, everybody. Now switch back to technical again. Yay, no budget here. So talk will be about DPDK Bus Updates. DPDK Bus is changing for a while, almost a year, and I will try to summarize the change and latest status so that it can be introduction to later talks about bus. Briefly, I'm working for Intel as a software engineer. I'm the DPDK developer and NextNet maintainer in case people don't know. Now DPDK has sub-trees, NextNet is one of them. And with latest technical board approval, I will also be helping Thomas on main tree as a co-maintainer. So what we will talk about is what's the bus infrastructure in DPDK and a little history of it. So bus and DPDK, since obvious bad joke out of way, then we can continue. A brief, quick history. Things started in version 1607. NXP approached and want to send their drivers. As far as I remember, it was Sharayan, but you also perhaps Haman. So discussion started at that point. There was some comments to fix bus first and then continue that discussions, continue. And in 1611, still, there were only two buses, PCI and virtual dev, virtual bus, and they were hard-coded in AEL. So in 1702, by help of Jean-Blanc II, he stepped in as well. The RT bus abstraction first implemented, but it wasn't really functional there, so it was part of AEL, but not doing much. In 1705, an XP bus driver goes in, as well as PCI and virtual dev buses now also using Neve RT bus abstraction. 1708, RT bus is expanded to cover hot plug functions. That work also done by Gayant. I am not sure if I'm spelling correct, but 6th guy. Then for this release, this is not final yet, but there are already some patches in mailing list. So target is move PCIe and virtual dev to driver's bus folder. That should be fairly simple because now that's logically separated. This is just moving from one place to other. DevArch's rework is on the way. Some part is already done. This will be more. We will discuss a little more, but this is making device arguments a little independent, not a little, independent from buses. And also a Neve bus is coming from NXP again. Patches are in mailing list. So this is very high level of DPDK, so high level, but what is here is an application and device functional layer and pull mode drivers. So the question is, where is the bus here? And nope, it is nowhere. The RT bus shouldn't be a problem of application developers. They shouldn't know anything about it. It shouldn't be interest of ETH dev, crypto dev, event dev layer problem. Of course, PMDs needs to know which bus they are, and they need to be able to communicate with device through that bus. But this is all, RT bus is all DPDK internal. So this is not something application developers worried about. What is the bus infrastructure in DPDK? Although we call it bus driver, it is not really driver. It doesn't drive bus controllers. It's more logically grouping devices per bus. And it has some responsibilities like scanning devices on a given bus. It knows how to match devices. Very quick example, PCI devices matched by device IDs and virtual devices matched by names, so basic string compare. So that information is in the bus, and it should know how to plug, unplug a device. Also, there are some set of PMD functions common, so they can be common for a specific bus. This helps us creating some helper functions to make life easy for Polmod drivers. So there are three parties in the scope of bus. I will call it ETH dev, but every time this is function level drivers, like again, ETH dev, crypto dev, event dev. I mostly will reference to ETH dev because I know it better, basically. And we have different expectations from these different levels. From AEL, it should be easy to add new buses. Adding a new bus should not cause change in core EEL code. And bus-specific code and function shouldn't be distributed in AEL code. So we are looking for kind of separation there. In ETH dev, functional device layer should be bus agnostic. It really shouldn't be doing specific to PCI or DPAA or virtual device. And again, we will see device some structs. It shouldn't cause change in ETH dev. Previously, it was like it. And sometimes we need to get some information that is known by bus drivers to ETH dev layer. Simply, I can think of interrupts. For example, we discovered them through PCI and we know them in that level, but ETH dev also should know about them. So that information still should be able to visible there, but in a generic way. So last thing, PMDs know about bus, and PMDs also need some information from that bus level thing, and that should be, again, can be done generic way. And helper functions we mentioned already. So current, after all those implementations, as now 1708, the bus process flow is now like this. In constructor level, each bus registered themselves, and that has been kept in a global list, RT bus list. Then each driver registered themselves to those buses. So bus maintain their device and driver list in themselves, so driver goes into that list. So there needs to be in order in constructor level, and this is done by giving a priority. So always all buses register themselves before drivers. Then in AEL init level, now in process main level, AEL init does for each bus calls bus scan, so independent from which bus it is. Then it calls bus probe, and within the bus probe for each device found for that bus, a common task which calls indeed PMD probe. So for each bus, each device has been probed. Probe is the last part within the PMD. So related data structures, again, with the latest release, not code, there are RT device, RT driver, and RT bus base classes, we can say. And there's a connection between device to driver. Then bus-specific structures inherited from these ones. Like for this sample, PCI device, PCI bus, PCI driver there. There's another connection between PCI device and PCI driver. And you can access from PCI driver to RT bus. It points to generic bus, not PCI bus. So, and in function device level for ETH device, it has only reference to generic RT device. This is the final state. So this will be more history of what was it and how we came to this level. Starting from 1611, by the way, that will be hard to read the screen, I'm aware of it, and that is not really needs to be read here. So we won't discuss those details. I will highlight the places with this kind of bubbles. So that's okay. This can be used for a reference for later, not for this talk. So highlights. There was no virtual device instance. Virtual device was directly referencing device arcs. So it was one of the things hard to make it generic. Then PCI device was embedded into ETH device. So for this case, when you want to end a new bus, then that means you need to go and change ETH device structure, which will break the ABI again. Every time you want to add a bus, you will break ETH there. And you will have a long list of buses there. And how to know which bus you are interested is also kind of problem. So most probably you will also keep a bus type kind of information there. So similar, ETH driver was inherited from PCI driver. So it was on top of PCI driver. In this approach, indeed, we are only covering PCI bus, and virtual bus is kind of hacked to work with. So although there looks like there are two buses supported, mainly one, and it is embedded on some certain places. So AEL init flow, again, it was hard-coded. There has been done a virtual device scan, PCI scan, virtual dev init, and PCI Pro. So these were API calls within AEL inits. And in PMD, that's how we call, how we register driver. Bus functions are hard-coded. And next release, 1702. Now there comes a new bus abstraction, RTE bus. ETH dev now includes a generic device instead of a PCI device. So even this one is one step further, but this is not solving all problems. So overall, this was a long-term development. In AEL init, RTE bus scan and probe added, but since no bus really registered themselves, they were not functional. They were just doing nothing. One more release later, 1705, ETH driver completely removed. VDAV device structure now created. And PCI bus inherited from RTE bus. So now we have a PCI bus, E-bus kind of thing. Now we have a bus code. Here we register our buses. So PCI has been registered using those structures. Virtual dev registered and NXP bus registers themselves. So AEL initialization code simplified, hard-coded bus gone. Now there is a bus scan and bus probe functions for each bus. So whatever registers himself, it will work. So when someone at this point wants to add a new bus, it will not change any EEL code. All change will be in a bus-related code, and with current folder structure, it will go into driver's bus something. So AEL is kept separate from bus. And PMDs are a little affected here, all updated already long ago, but how bus driver represented change a little. Not much, so that was not too bad. In 1708, now bus is improving, new functions added for hot plug support. Basically, it's easier to understand, find device plug, unplug, what they do. Parse is a little hard to understand, and I think it will be temporary. Also, in this release, device arg updated and bus-specific names removed from it. That parse callback for each bus is to parse string representation of a device. This is because in DevArgs we can sometimes provide a PCI address or VDEV name as a string. So that needs to be bus. So that parse now helps us. That has been handled in each bus individually instead of, again, part of AEL. In AEL init flow, nothing changed. We are still same there. And data structures, no change, but we still didn't release it, so we may have, we don't know. And there is already a patch for new bus type. So if it goes in, now we will have 4 bus in DPDK. And there's no change in init flow for this release. So what is to do in this release? What we have? There are already patches in mailing list to move PCI and VDEV into driver's bus section. So that work is already done, that has been implemented. Who will be maintainers of driver bus? Kind of 4 vendor-based ones. I believe vendors will be maintaining that code. For PCI and virtual device, anyone willing to maintain that code? That will be great. And there will be more DevArgs rework, and it will do more separation of device arguments from buses. So it should be bus agnostic. Right now, PCI whitelist is so much PCI whitelist and PCI blacklist. That should be generic. And there's also another type of bus submitted in patchwork is driver's bus net. It's a virtual bus submitted by Gaten again. And I think that's only targets Mellanox devices. So a virtual one, we don't know what will happen with that one either. And not this target for future. Most probably I will expect we will see Hyper-V VM bus. Steven has a talk already today, and those patches submitted previously to patch mailing list with old bus infrastructure. So I would expect they will come. Add remove notifications for hot plug, more hot plug developments. More explicit and extensible DevArgs. Remove RT bus reference from DevArgs. Again, these are DevArgs improvements. And something perhaps we are missing is bus documentation. Because all these spread through a year and not really much documented. Perhaps because it's kind of DPDK internal, but still in the future it can be good to see some documentation for this area. And thanks for the people who did this work. The first names I can remember, Sharan started the thing, Jem Blanc, and now Gaten. And I'm sure there are more people helped there. Sorry if I missed their name, and thanks to them as well. That's all I have. Any questions? Since this is so... yes, there's one question from Thomas.
Yeah, that's not really a question, but please can you go back to the to-do list?
This one?
No, the previous one.
This one?
Yes. Okay. I want to talk about the whitelist blacklist feature, because this morning we were talking about giving more power to the application, and this whitelist blacklist is exactly an example of what DPDK is doing instead of the application, because we are just providing a way to the user to whitelist or blacklist a device when initializing the application. But maybe the application knows better than the user, which device they want to use, and maybe the application has other ways to configure the whitelist, blacklist devices. This kind of thing. Maybe we can whitelist.
Is it like whitelisting a device even it is not existing? Do you mean?
I mean the application can have some rules to know which device to use.
Okay.
And maybe it's not needed to ask the user to configure this rule. This rule can be hard-coded in the application. And maybe we can whitelist some devices dynamically, and so it can be done by the application. So for all these things, my proposal would be to, instead of providing some whitelist, blacklist options, just to do some notifications each time a device appear or disappear. And especially when a device appear, we can decide if we want to use it, to initialize it.
Or
so if this notification goes to a layer inside DPDK, we can decide inside DPDK that for sure we want it or we don't want it. And some libraries, for instance, could do that. And then the notification can also go to the application. So and if the application wants to give the decision to the user, it is a choice of the application to use some rules parsed from the users. But again, it is a good idea.
Now it's so static, everything is done in AEL level with given parameters. Bruce has something to say.
I agree and yet also disagree with some of those points. I think the last comment that Thomas made about is possibly the most relevant, about the application deciding whether or not to pass the responsibility back to the user. And I think that's the key thing. I could certainly imagine there are situations where, yes, it is the user really who needs to determine what devices are going to be used for this particular application. An application shouldn't, or a lot of applications wouldn't be written to use just one device type, or just one brand of NIC or something like that. They would have all the drivers in it, and then it's up to the user to select. On the other hand, I could imagine scenarios where you have the opposite, where the application does want to be the one deciding. So I think the most relevant one is there. It should be the application deciding how much information comes from the user and how much is built in. But I also think it applies to more than just blacklist and whitelist. I think it needs to apply to so much more. Again, coming back to the amount of memory being used by DPDK, all the other arguments that we have. So I'd view it not as a RT bus, RT device, DevArg's problem as more just a overall command line application problem. We don't have an easy way right now for the application to manipulate the parameters going to EAL, apart from building up its own EAL argc argv, which is kind of a hacky way to do things. It comes back, I think, we're coming back to the same problems again and again in terms of being all-encompassing, assuming that DPDK gets the command line arguments and is in charge of the command line, when in fact it shouldn't be. It should be the application in charge of the command line, and the application should decide what parameters go to EAL and init. And right now we don't have a good way of enabling the application to do that, except saying, go create your own argv array and pass it into us. So
not good array, but still
I think it's more, yeah, it is. It is a more general problem, in my opinion. So.
And there is also, just a second, some patches about UDEV, using UDEV for hot plug, removing, adding devices on the fly. Have anybody seen them? But yeah, there's another patch set waiting there for reviewers.
I totally agree with Bruce that this is a generic problem or issue or topic. I think that the whatever you pass on a command line can be interpreted by EAL or whatever deeply into DPDK, or it can be interpreted by the application, and then the application, by using runtime libraries, part of DPDK, set up whatever would be otherwise hard-coded and not dynamic because it's a configuration thing. So I strongly prefer libraries to set up things rather than command line issues. For instance, our application, the first thing it does at startup is determine what kind of hardware am I running. So we are building hardware appliances. What kind of hardware am I running on? What's appropriate for different sized tables? What's appropriate for which port modules are plugged in? What Ethernet modules are in the ports and so on? And we need to be able to do all this runtime because we're not making, otherwise we would need some application to determine, so the same hardware I'm running on, so when I'm done determining the hardware, the bus using bus library, then I would have to shut down that, set up a part of configuration files, and then fire up DPDK one more time. So generally I prefer libraries and functions rather than configuration lines in all areas.
I'm hearing two things. One, device arguments should be replaced with API calls, easier to use by applications. I think nobody really prefers device args, but this is just how it was implemented, so we keep using that way. That needs to be perhaps planned to change. Second thing, there is no way to get capabilities. I think you are saying that one too, no? There's no API calls to get underlying hardware capabilities.
No, that's not an issue for us because we know when we scan the PCI bus and we see this is that device or this is this NIC, then we know exactly what it can do and what it cannot do. And we build our own capability registry that makes sense for us, for our application.
Yep.
And we don't need the DPDK. Well, we don't need it. Someone else might need DPDK to expose that.
Two are, I believe, valid concerns, but not directly related to this one. There's bigger things. What Tom is suggesting with whitelist, blacklist is, as far as I understand, a little different. That concern was not using device args, but being more dynamically whitelisting, blacklisting devices, I guess. But yeah, I agree your comments. Only there is no plan to change them as far as I aware.
I'm just adding to what Bruce said, that whatever you can do on a command line, you can also have the application read the command line, do something, and then make it more dynamic by having library functions to call instead of the application not being able to do it.
So just a quick question. So how do you make sure that you can run like, I'm here, like 4 DPDK application? So that's a use case that may appear with containers and
right
others.
now we are doing it with whitelisting.
Yes. So
by default, DPDK takes over all devices.
Exactly.
So you can give parameter to whitelist them, so you can divide devices between multiple DPDK applications. But perhaps it can be also done dynamically. You can have multiple DPDK processes, and you can, after that, dynamically assign one device to one process and then change. But yes, right now we are doing it whitelist. One more question. No, that's
Okay. I also think that we need to widen the scope a little bit and get rid of as much as possible all the helper scripts, because having a bunch of hardware discovery and stuff buried in some Python script that's sort of half there doesn't help anybody making a product. We really need to kind of integrate it into part of the API and pull some of that out of there. I mean, some of it maybe you have to do on the command line, but some of it seems to be a lot of stuff that's sort of walked its way out into scripts.
Yep, I see. Right now we need to bind some devices to some modules to make it usable. By DPDK, you are suggesting making it more dynamic within DPDK. Makes sense, yep. But I don't know how it can be done. But yep.
Yeah,
Thomas?
I
Last
agree.
one, sorry.
Sorry, I agree with Stefan. For a true hot plug, we need to be able to bind devices to the right kernel module dynamically. So instead of relying on the user to do this binding, we must integrate it in the PMD. I think it's mandatory for hot plug.
Integrate into
Because
PMD.
before starting your DPDK application, you are using the script bind, I don't remember the last name, bind Nick binds, yeah, something, the script. But, okay, but when you want to use hot plug, if you have not bound your device, it won't work. So we must just drop the script, actually. It is the right goal. Because this script is against the hot plug feature. It just defeats the hot plug.
So can I ask a hard question? Is it in the roadmap?
No. But, yeah, I think that's something we should agree and then put on the roadmap. But you are asking a good question, because the main difficulty with the bus rework is that there is not enough people to work on it. We can express what should be better, but there is few people working on it. And you well shown the history. We are now 1 year and a half from the beginning of this rework, and it's not yet finished. And I expect it to take few releases again.
Okay, so something
and I agree, we must agree on the roadmap, and then we must find who should work on it. That's a very hard question.
Can you say more discussion will be in mailing list?
Yeah, of course. And excuse me, I see Bruce is back again. I want to explain better my proposal about notification. I agree with you about having better API for this kind. I agree the bus rework is really tied to the better defining the dev-args. But I think we cannot configure the whitelist policy only with dev-args, and we cannot find a suitable API which covers every use cases. For instance, if I have an application which wants to use only the devices which are on one new method, or only the devices which are red, because my application is red, I don't know. yeah. If we use the notification system with a callback, the application can implement a callback which does the right checks on the device and choose to use the device with its own rules.
I would suggest discussing more in mailing list. Yep.
We have questions, so we have to kind of keep this on track. We can discuss this in little groups. There's clearly a lot of interested people. So just to summarize two things, was that request for a maintainer there. There's clearly a lot of different interests, so I suggest splitting this off into a hallway session and whatever. But so thanks very much, Ferru.
Thank you.